Thank you very much, everyone. Good afternoon. I hope everyone's enjoying the conference. The keynote speaker was pretty good, wasn't he? I really enjoyed his talk, and a lot of what I'm going to be talking about this afternoon is related to what he said. In fact, I could almost say that he said everything I'm going to say from a different point of view and in a slightly different way. So in the interest of being provocative, my talk, 3 myths and 3 challenges to bring system administration out of the dark ages. I'll say what I mean by that in a minute. So I want to talk to you today about some changes that are happening in our profession. And I want to do it by taking a relatively small number of technical ideas and putting them into a larger perspective. I was very happy to hear Ben Rockwood's keynote because I think he really put his finger on a lot of these things as well. So there's a very clear change taking place in the profession, the way system administration is being done today. And we're seeing this change across a wide range of organizations, not just the Web 2.0 companies that are sort of driving the idea of DevOps. In particular, the proliferation of mobile devices is driving changes in the way that we support IT systems, the kinds of IT systems we want to support, and the way in which we have to support them. Creates companies and organizations of a particular type, which means we have to work in a particular way, we have to adapt to new situations. And this is creating a wave of change. And I think that DevOps is one expression of that wave of change. I want to try and represent where we've come from and where we're going to, and mention some concrete examples of the progress that we've made, and maybe try to put them a bit into perspective and say what DevOps might mean and perhaps even where it's going. So you must excuse my drawings, since I don't have good artists. I have to make these things in my notebook. Now, Dark Ages. Dark Ages are in fact a time in human history where intellectual and cultural activity was at a low, and violence was the main form of expression for solving problems. We were apparently rescued from the Dark Ages by the Enlightenment, or some of you might disagree, when it became fashionable to think that we were able to think about doing things again. But for many years, brute force was essentially the way that we solved problems in the arsenal of a governor. Now, in system administration, there is a kind of dark ages still going on in a lot of places where brute force methods are still widely in use. And we tend to perceive, system administration as a plague of frogs raining down from the sky, or attached as attachments to support tickets or whatever the transport medium is. And these tickets fall down and they basically schedule humans to work as a kind of a machine, solving these things as they rain down upon us in a kind of a situation of oppression. And we then apply humans or blunt force instruments to try to swat these frogs away, or this plague of bad things. And this is the way for many people, system administration is perceived: firefighting, frog fighting. Wouldn't it be nice to have a more positive view of engineering? Well, so there's then the kind of Enlightenment. So if we're following history, we could pursue this a little bit more, but rather than dwell on history, to cut a long story short, we went from the Dark Ages through several centuries of ugly paintings and poems about love, and people renounced violence in favor of thought and modern thinking, or at least up to the point until we reached a technological age where we could make tools that allowed us to do violence at even greater scale. And then we came back to this point of view. This brought us to some kind of industrial revolution, as it turns out. And industrial techniques have really taken over the world and allowed us to scale up from simple doing things by hand, and allowed us to scale up the size of things to escape from that poverty trap of just responding to frogs falling from the sky. So industrialization is very important, but it also binds us to a way of working which is somewhat unfortunate. And to use an Enlightenment example, I often use the case of, how many sysadmins does it take to change a light bulb? And to make a joke, actually it could take quite a lot, because a typical industrial method is to demolish something and then rebuild it, to wipe a computer clean and rebuild it. So a sysadmin would probably demolish the building in which a light bulb wasn't, and baseline the system and build a new building that contained a light bulb. This is the way we re-image systems. It's a very wasteful way of approaching the problem. Now, we've accomplished all kinds of great things with industrialization, everything from gardens to technological gardens. And if you look at these two cases of beautiful configuration management, they actually contain a lot of the same themes. One was performed by hand, perhaps with the aid of a little bit of machinery. The other was performed by hand, perhaps with the aid of a little bit of machinery. But there was a lot of manual work involved in the setting up of these things. Over the years, what we've really done is to increase the size of installations in computer systems using basically old-style, old-school industrial techniques. And very few of the techniques have really been modified to adapt to the modern reality of these mobile devices driving new kinds of companies, requiring the diversities that we crave. And if you look back at the history of Lisa, go back to some of the early papers. Some of the early papers were things like how to install 100 machines in a day and still have time to mow the lawn. And now, if you look at the papers at Lisa, it's pretty much the same kinds of themes, how to install, well, thousands or tens of thousands of machines in a day and still have time to mow the lawn. So in some ways, we haven't progressed very far. We've simply scaled up using these industrial brute force techniques. And these techniques are used for things like rollouts, industrial machine rollouts, how we deal with alarms, tickets, frogs falling from the sky, and how we roll back from problems and mistakes that we've created, and typically how we organize these systems into hierarchies, which are the industrial point of view for organizing systems. So industrialization is going to be my target for today to make fun of, because I like making fun of old ideas. What I want to do is to put these things in the framework of an idea. And this idea I discovered again recently, I mentioned it this morning in the keynote. It's an idea from Alvin Toffler about 3 waves of civilization, 3 waves of change in a civilization. And these 3 waves basically follow the pattern from manual work to modern times, the information society. The first wave was the agricultural wave, or doing things by hand. Typing on a keyboard in IT, fixing problems, running around to the computer, the Adidas method. You run to the computer, you fix it, you connect to the system, type on the keyboard. It doesn't scale very well, but you can accomplish quite a lot if you have sufficient brute force. Then comes industrialization, where we create machines, cool machines that can scale up human activity and allow us to mass produce our way out of poverty, creating many, many things at large scale with amplification, but they're all the same. One size fits all, any color as long as it's black. It's the Henry Ford production line. Industrialization is great, but it binds us to a very singular blinkered vision, which is that one size has to fit all. And what it means is that people have to adapt to the technology, not the other way around. Always the technology should be designed to serve the human and not the other way around. So then we get to the information age, which is where we're making a transition to today. And in the information age, diversity and individuality come back, and humans then once again drive the reason for the technology. We're no longer forced to accept the thing that industrialization makes for us, but we insist on diversity and individuality, and the technology is forced to produce that for us. And this is what these amazing devices are doing for us, giving us the autonomy and the freedom that we crave, and then forcing the back-end technologies to support this. And this is changing the way, of course, that system administration has to be done, because we need to be able to adapt to this scenario. So when we reach the third wave, diversity and freedom become driving forces for change, and these old clanking industrial models basically don't cut it anymore. So, 3 myths. I want to challenge this industrial view with 3 myths that we basically still believe in system administration, I think, and I want to try to convince you that there is reason to doubt these methods. So, first myth, ordered sequential control. We must order things, or why British people like me like to queue up. So, installing computers, checking file systems, rolling out changes, scanning and searching, these are all things that we do in serial and sequential ways. And, as children of the second wave of post-war industrialism, if you like, we've basically been taught to think in this way. We've been taught to think that we do things through flowcharts, imperative programming languages, shopping lists, to-do lists. Everything we do is basically one after the other in a sequence. And it doesn't really occur to us because of the production line thinking that we could parallelize something and solve the problem perhaps more quickly, or, for example, solve something in a random order, and that might actually be quicker. That's interesting because, Dijkstra's algorithm for crossing bridges and finding the shortest path across bridges is in no way a sequential representative of a sequential algorithm. We know that optimized techniques don't necessarily involve sequences, and yet we have been drilled into thinking sequences as a matter of history. Before the industrial era, of course, many people worked side by side, hand by hand, side by side in the fields, working agriculture. And before that, again, people hunted in the forest in groups in parallel. The parallelism was more important, perhaps, before industrialism. It was only when we tried to imitate humans in factory line processes that this serialism came back. Various other things came along with the sequential thinking, in particular the way that humans work. So this same industrial era turned humans, or at least Dolly Parton, into 9-to-5 workers, clocking in, clocking out, scheduled time, basically being scheduled like a cron job to work at fixed times. Today, things are, in an information society, we expect to be able to be much more flexible and free than that. We want flexi time. We want to come to work when we want to, go and work somewhere else when we want to. We want the freedom to exploit that, or we want to be able to exploit those freedoms and not be channeled into a serial clockwork kind of universe. And there are all kinds of ways that we see today with new technology to be able to handle those things. We can pick things in random orders. We can do things in parallel, multi-threaded. All of these technologies make possible optimizations that were not possible in the serial world. This is something that comes up in configuration management a lot, that we have to do things in a certain order. And of course, if you believe in industrial destruct and reproduce techniques like our light bulb screwing system administrator, then serialization is a natural way to think, because if you only have serial methods, you have to know where you start from. If you can only go in a straight line, you have to start in a good place to end up where you want to be. So this binds us to a way of thinking which is both industrialized and a little bit oversimplified, a bit simplistic, and generally inflexible. Here's an example of something which has been serialized, which really shouldn't be. This is XML, of course, and you see that these books have been coded into XML in a particular order. This order in no way reflects anything important about the books. The books weren't written in this order. They don't have to be read in this order. They weren't even ordered this way on the shelf necessarily, but we simply have to write them in this order because of an artificial quality of the language which we chose to represent them in. So you see that culture, the culture of our expectations and our technologies can imprint a way of thinking on problems. Now, it turns out that you can optimize problems quite a lot by going away from serial thinking, parallelizing things. And there are even methods called Monte Carlo techniques where you choose randomly from a sample to be able to optimize the evaluation of a search, for example. Binary search is also an example of a randomized function. So serial thinking, we don't need it. We could get rid of it. So let's not even imagine trying to keep it when creating technologies for managing systems. It doesn't scale very well. Myth number 2. Determinism and rollback. or why you shouldn't work in front of trains. So one of the other myths that was crushed during the 20th century, crushed, was the idea that the universe is a clockwork device that can be wound up, it runs forward, again in a serial way, and that can therefore be rolled backwards and undone. All of the changes in the 20th century denied this. The introduction of probability, quantum mechanics, thermodynamics, statistical methods, all of these things told us that the world is not necessarily deterministic. It turns out that time, in fact, does have an arrow, that you can't just roll things back arbitrarily. The second law of thermodynamics actually says this, right? And if you ask the guy who walked in front of the train, oh, you can't. Actually, it doesn't help to roll the train back, because even if you could pick up the pieces and put Humpty Dumpty back together again, you're not really achieving the same state that you started with, because by the time you've put him back together again, the rest of the world has moved on, and they maybe don't even remember who he was. And it's the same with computers. We can try to isolate certain things. We can, for example, computer gets attacked by virus. Or bug in firewall. Computer gets attacked by virus, fix bug in firewall by rolling back. Computer is still infected by virus. So we have to repair anyway. We have to pick up the pieces and put it back together again. So if you believe in a clockwork deterministic world, or if you're Cher actually, then you believe you can roll back time. Unfortunately, it's not true, and this myth comes out really of this term rollback, which was usurped from database theory. In database theory, what you do is you create a small enough world that is so isolated from its outside that you can literally almost predict exactly what's going to happen for a very short amount of time. And you can make a change, and you can undo that change because you've isolated it to such a high degree. In thermodynamics, if any physicists here, you know that in thermodynamics you can do the same thing. And it's called an adiabatic system, an adiabatic change. It's where we get refrigerators from. But as soon as you open up to a wider world or make things happen over longer times, this becomes impractical. We do a lot of rocket science in system administration. We do a lot of planning in projects. And the way we do it is to save up these big changes, get experts to work on problems over a long period of time, lead a lot of tailor-made expertise, putting together into a large project, which we roll out on a certain date. We blast it off on a certain date. It's a very irreversible, high-risk kind of change. Once the rocket is blasted off, it's very hard to roll it back. And that's because we've saved up all of our changes into this one very high-risk opportunity. The challenge or the genius of business is to turn this rocket into something much more predictable. And this is amazing, right? You take the idea of a rocket, you say, that's no good. We want something we can commercialize. We want something that's reusable, easier to build. It doesn't require so many trained experts. If it goes the wrong way, well, you can just adjust its course. It doesn't have to fly off and explode somewhere. If you don't like what it's carrying, you can take out the seats and you can make it carry cargo. This thing is a much more flexible, reusable device than the rocket. And, excuse me, you can actually roll back a 747 in the sense that you can reverse the course and go back to where you started from. Of course, it's not really rollback because the plane doesn't fly backwards and the passengers don't deplane, whatever you call it, walking down the steps backwards. But you can go forwards in a way that is going back to where you started from. So it's possible to back out of ugly situations. But it's not the same as rolling back. And I think what's important to remember is that undoing change is not going back in time. It's not an easy way out. It's actually hard work going forwards to plan to get out of these changes. So myth number 3, hierarchy or bust, or why trees are losing to human beings, or why squirrels get lost looking for acorns. This is another feature of the second wave industrialization. Hierarchy became very popular. And it's easy to see why hierarchy became popular. there's actually an economic reason why hierarchies occur. If you have somebody working on something, that creates a serial process which doesn't scale very well. So you introduce more of these, and as you introduce more of them, you need to coordinate them. That means you tend to introduce a coordinator or a manager. As you get more of these managers, they need to be coordinated by another level, and you end up creating a kind of a hierarchy. And a lot of human society is built in this way. So we tend to imitate human society when we make technologies. But the problem with hierarchies is that they create these rigid, brittle structures. And as you see, they're quite easily to destroy. They have single points of failure at every node in a tree. If you destroy any one of these branches, you cut off part of the tree from itself. There's a related problem here, which is what you try to do with a tree is you try to marginalize a problem. You classify something down in a very special way and put it into a particular category, for example, in a file system or in a database or in a system administration model or in an organizational model. You categorize something in one place and you've cut it off from its neighbors. In order to find its neighbors, or in order for the squirrel to find its acorns, you have to go all the way back up the tree through these single points of failure and hope that none of them have been broken. This organization is not very efficient either, because the reason we break things up into levels in the first place is because we don't want to see too many things at the same time. But as soon as we start hiding them away, dare I say, squirreling them away into subtrees within the tree, you have the depth versus breadth problem, which is that you have to descend into these things searching for your acorns because you can't see them from the top level anymore. So hierarchies, although they're simple to understand and they seem to give the illusion of predictability, they're in fact very fragile structures and they're easy to get wrong. It's easy to see that they're easy to get wrong because if you ask any duck-billed platypus, you'll know that he's not allowed into the mammals club with his eggs. You can't classify something in two distinct categories without breaking the model. If the model is broken, then it's broken. So C++, why do you need friends in C++? Well, because hierarchies don't work. So hierarchies are very fragile structures. You probably feel provoked, because I'm a provocative thinker apparently. You probably feel provoked by this, and this is good because it's important to hold up a mirror to these things and look at ourselves, look at the practices that we have. What's the alternative? Sets. People tell me I think way too much about sets. But this is a more general approach, and this is the approach we took in CFEngine to categorize diversity. Instead of trying to put things into hierarchies where things get lost down one particular branch and cannot overlap or connect with other things, we can form things into overlapping sets. And you know what? There's absolutely no reason why sets shouldn't overlap. So, those are the negative things. What about the challenges? Well, complexity. The challenges of today, I think, are complexity and scale. And this is being driven by the diversity of the freedoms, the personal freedoms which we crave in this information society. Architects, it seems, can handle complexity fairly well. But in computer science, we're rather skeptical of complexity, and we try to break things down into rather oversimplistic structures very often. I think the most important thing we can do going forward in computer science is to start by looking at what we've got. This is a more scientific way of judging a system. Why impose a structure on a system before you actually know what it's supposed to do? Evolution, of course, seeks out certain patterns and creates certain structures because these things survive. Evolution is basically economics. It's the economics of survival. And if something is stable or survives in an evolutionary framework, you know that it has some basic stability. So why not begin with that stability and work around it instead of trying to reorganize it and see what happens? One size does not fit all. So if we try to create a hierarchy and force people into a hierarchy, then you're most likely to satisfy a small number of the cases, but there will be lots of cases that don't fit into this model, and you'll pretty much end up making a system in which nobody is particularly satisfied with what they got. This, of course, is the mass production way of thinking. One size does not fit all, unless all of you would like to speak Norwegian. or all of you would like to drive cars that are black. In order to handle complexity, we can allow emergent structures. And today's IT is not really a Swiss watch. It's not a mechanized device from the second age industrialism with one production line and a nice predictable chain of events. It's actually a much more of a muddy ecosystem with things interacting in complicated ways, technologies overlapping from multiple manufacturers with users using applications of all different kinds. Why would we want to force people into one way of working when we could be able to support that kind of diversity? So what the third wave of technology is about is being able to support this diversity and having the technology that makes it cheap to support this. Toffler made this point very beautifully. He said that the point of technology is not to make everything the same, but to make it cheap to be able to support diversity. Commerce. So the second challenge for system administration is to recognize the importance of commerce in the development of the IT society. In fact, to recognize that IT is a society, it's not just a computer or a computer system. In fact, a computer system is a human computer system because humans are a very important part of all IT. It wouldn't exist without it. And in our third wave information society, commerce plays an increasingly large role. It was commerce that invented the iPhone. It was commerce that invented pads. And commerce, in fact, that drove the expansion of the internet. Okay, so it was DARPA who invented the technology, but it was commercial websites that caused the explosion of the internet and drove it into people's homes. So commerce has played an incredibly important role, and that means that the net is no longer dominated by big corporations or singular monolithic structures. Again, there's a need to support this diversity. And this brings us back to 747 thinking as opposed to the rocket science. To be able to survive in this kind of structure, we need to be able to support the opportunistic. And we need to be able to allow people to have goals that they can focus on in business to build up businesses. To survive in business, they need to be able to align with certain goals. And these goals often are in competition with one another. And in order to survive in a competitive environment, you need agility. So you need to be able to respond quickly, and this brings us also back to the other issues of serialization and parallelization and avoiding these old myths from the past. So we need tools in this third wave that can support diversity and can support agility in order to support competition, in order to drive the technology that gives us all of this cool stuff. It's a self-fulfilling prophecy. It's an evolutionary, stable strategy, if you want to call it that. Here's an example of second-wave thinking versus third-wave thinking in technology. I made this just for fun, having seen this picture. On the second wave, of course, you would introduce some ridiculous tool and you'd have people standing around talking about their tools like men do. To clear out a flood. And then in the third wave, people would just laugh at this and say, why not just make the technology self-heal? In the third wave, we need to put infrastructures into the walls with the pipes and the electricity and the drains and all of the invisible infrastructure. It can be self-sustaining, self-healing. We don't want to see it. You don't want to bring out these massive machines on a manual basis and force humans to work for the technology in a completely unnecessary way. It's very easy to see that technology drives society. If you look back at the history of the 20th century, before the Second World Wars, people were all about big civilization, big infrastructure, and designing systems on a large scale. It was all about monolithic societies. Look at the movies like Metropolis and the old science fiction movies prior to in the 30s. They're all about these fantastic monolithic civilizations. Of course, after the war, people were very concerned about their freedoms, and what drove their thinking then was the ability to do what they wanted. So instead of ushering in a third, and the next chapter of the Roman Empire Italians bought scooters because they wanted to go places and do stuff and be cool. They didn't want to act as a society, they wanted to act as individuals. And this trend has continued to today. We want to act as individuals, so we buy iPhones and pads that give us the autonomy to be able to work without mainframes. Instead of going to a building where a computer exists and sitting down to use it, we bring the computer to us. The computer comes to us. It's obvious when you think about it, but to support that kind of technology, the infrastructure has to be quite magical, has to be deployed, and it has to be separate from the technologies that it supports. And this is where system administration, of course, is going today. This picture I took from, this is from the midnight vigil in Oslo. During the summer we had this bombing and massacre in our city. And this midnight vigil, nobody's mobile phone worked. We couldn't send a single text message or phone another single person because this old-fashioned spanning tree technology, which we used to support cell coverage, just failed. It didn't scale to this kind of problem. So this old hierarchical way of thinking survived up to a certain point, and then it failed miserably. I was in New York on Friday on Fifth Avenue, and it was basically the same story. People out shopping. I couldn't get a single text message through or a single mobile signal to work. So to support these technologies, we need to think in new ways, new structures. Maybe networks have to be ad hoc at times. Maybe they can be hierarchical or they can form hierarchies, but they also need to be able to adapt in other patterns. Third challenge. The third challenge for system administration is really a challenge for everyone. It is the challenge of the decade. And that is knowledge management. How do we manage the knowledge when diversity and information explodes in complexity? Then we need to be able to have ways of understanding what we've seen. It's one thing to build a system and to scale up to hundreds and thousands of machines in a data center, but then you also need to know what is the monster I have created. How do I perceive it? How do I understand it? How do I track it or even follow it? How do I know when something has gone wrong, and what can I do about it if it does? In the third wave society of information where people have great freedom, they also have the freedom to go and do something else. They don't have to stay working in your organization forever. In the industrial age, you could replace people because everyone was programmed to work for the technology. Everybody was brainwashed to follow some best practice, some recipe, some simple way of working, some clockwork procedure. But in the third wave, people have much greater freedoms. They want to do other things. They want the technology to work for them. That means, far from system administrators becoming less important in the third wave, we are much more important. And individual skill is now irreplaceable. You can't take one system administrator and replace him with another because expertise is now at a premium. On the other hand, when technology absorbs more of the expertise into it, for example, in the drain, when the drain takes away the whole thinking about the problem of cleaning away garbage or absorbing water, then people maybe lose the skills to do that by hand. So certain knowledge disappears from public consciousness, and we end up having a quite different profile for people working in technical activities. We often think that people get dumber with each generation. Oh, they don't learn the old ways, or we don't learn by rote anymore. We haven't memorized the capital cities of Europe, or all of these things which were very important in the second wave industrial thinking. That form of learning was very production line, very factory oriented. You learn by rote certain things. You have best practices. Today, in the information society, best practices are much more tailored to specific requirements, individual needs, individuality. And that is what we need to make cheap to support. So knowledge management is the challenge that we face for the decade. It allows us to bring context to something, meaning to something, not just scaling up enormous size for no good reason. And it allows us to apply experience to the problem. So instead of creating a hierarchy, you look to see what you've got and try to work with that, work with the environment instead of against it. Instead of trying to dominate the environment as we did in industrial times, we try to work with what we've got, adapt to it. This is the way that technology is changing, and it's also the way sysadmins will have to change. It's interesting to see some of the companies we work with in CFEngine. Even big monolithic things like banks, which you wouldn't expect to behave in a federated way, are now finding that they simply cannot scale complexity to the sizes that they need without federating things, without saying, okay, you can do your thing, you can do your thing, and we'll integrate them loosely instead of imposing one size fits all on all of them. The way we do it is to use information, patterns, to look for understanding, and use those patterns to compress the total amount of information so that it becomes simpler, it becomes cheaper. That is the way forward. Who needs knowledge? Everyone does. Infrastructure engineers in particular, which is you guys, need to know where the pipes are. They need to know where the infrastructure that we've stuffed into the walls is kept and what to do about it when it goes wrong, because when it's out of sight, it's out of mind. So some part of us, the system admins are never going away, but the infrastructure engineers will have to have the knowledge to be able to find the things that are buried out of sight and fix them when everyone else is just floating around with their iPhones on top of it. And of course, meaning is much different from information, so understanding something is a completely different matter. These two web pages show this quite nicely. On the left-hand side, you have basically noise, incomprehensible website. On the right-hand side, you have something very easy to understand, which contains little information. Little information has more significance than more information because it's less noise. Washington Monument, a logo, or a peak in a distribution, this is what is a little information. It's something that stands out from its background. We need to be able to identify things that stand out from a background of complexity and noise in a technological landscape that is increasingly diverse and complex because it supports the freedoms that we crave. So, who knows, maybe the term system administration will actually die out in our industry. I don't know. I don't care, actually. Maybe we become infrastructure engineers and IT shepherds and whatever the different roles are. Personally, I'd be happy to think about us more as engineers than as administrators. I think it's more representative of the kind of skills that we bring to bear on the problem. If we look at the education of children, the skills are changing very much from learning by rote to more analytical skills, the ability to find information within a large basis. It's also the social skills in the social media, which are coming back, having basically eradicated social skills in the second wave when everyone was working in a factory. You just learned to go to the factory and do your job. It was very dehumanizing. Now we rehumanize the world again with the diversity and the individuality that we crave. And that means that we return to a social way of thinking, which is what our brains were really designed to do. So it's an exciting time, it's an interesting time. And it's one that we have to think very carefully about. How can we apply those social skills to manage IT as a society? Because IT is a society. I think we have some goals to address over the next few years. And how can we help system administrators to go forward and adapt to the new world, to raise themselves in the status of society in general? I think the way to do that is not to fight for the old way of thinking, not to resist change, but to embrace the kinds of changes that we're seeing today, and basically ask the right questions. So with that, I would like to thank you for listening to a provocative thought about the future, and wish you all a very nice conference. Thank you very much.
We have a few minutes for questions. If anybody has any, please come up with the mic.
Wow. Did I industrialize you to silence?
It was so provocative. Right?
It's like Monty Python. you have to say, think for yourselves. Yes, yes, we'll think for ourselves.
So early on you talked about the sort of eliminating sequential thinking. Does that mean that we're going to dump the von Neumann architecture entirely? Computers are just going to work differently, and because they are kind of inherently sequential today, and to be a programmer, you have to be able to think like a computer.
Ooh. You made me think.
Oh, good.
So electrons only go in one direction at a time. Actually, that's not true. We don't really know how electrons move.
They're probability fields, actually.
Yes, exactly. But they seem to flow in certain directions at the scale of electrical circuits. So there's in some sense in which there is a linearity to the flow of computation. But of course you have things like pipelining and parallelism and what have you. It's the way you organize the use of those resources, I believe, to solve problems, which is interesting. Actually, in quantum computing, you have individual atoms in parallel solving things absolutely in parallel. So who knows what the algorithms of the future will be able to compute in a parallel fashion. I don't think we necessarily have to, I don't think we're necessarily forced into serialism. We'll see what technology does to bring, but that's an interesting point. I'll think more about that. Thank you.
The reason we have trees is to avoid the factorial, or I guess actually quadratic increase in information flow that's required. If you try to parallelize something that has been hierarchical, then you've got to find a way to minimize that communication so that it doesn't become too expensive. Subcomponents are never going to lose their sequential access, but they may get very small. Like our cores have gotten to a certain point, and they're not getting any bigger. They're not getting more resources to themselves. We're just getting lots more of them. And so we have these subcomponents that are sequential, but they're going to have to cooperate in parallel. There's memory locking, which tries to impose serialism back on the thing, and which gets you in trouble. I've been recently studying Erlang, and I'm very pleased with the actor model where you keep your own copy, and you don't have to know whether the other fellow's changed his because that was convenient for him. So you reduce the communication to what is utterly necessary, and you keep your own state private so that you don't have to have these memory locks.
Okay, so there are a hierarchy is, of course, I dismiss the hierarchy as ridiculous just to provoke you. But of course hierarchies have their uses. The trouble with a hierarchy is that they're not unique, right? Generally speaking, you have a network of relationships in any kind of system, whether it's a society or a knowledge base, a knowledge map, or whatever it is. And all a hierarchy really is a spanning tree for this particular network. The thing about spanning trees is they're not unique. You can start from multiple points of view and cover the space in different ways. And and that's a perfectly acceptable algorithm for computing things. The mistake is in assuming that that is unique. So our duck-billed platypus doesn't really like being both a mammal and an egg-laying creature. But he's forced into this uncomfortable situation by an inappropriate spanning tree that somebody's particular point of view put on it. In Victorians, they created these phylogenetic trees for species which were quite ridiculous because they were all designed to make man look good, be at the top of some ladder and be the best. So there's often an agenda behind these hierarchies as well. Who is most important? There's a ranking of things which is often inappropriate. And in terms of communication, a hierarchy is somewhat inefficient, as with the mobile case. You can have certain trunk line communications that can reach efficiencies, like the trains, for instance. The trains mass communicate people from one place to another, but they only go from one place to another. you need packetized cars to be able to travel more flexibly at certain ends. So you have multiple strategies for covering a communication space, not just a hierarchy of point-to-point links. You know, a hierarchy of trains would never cover America very efficiently, but having a mixed strategy between a hierarchical backbone, perhaps, and a packetized cloud of things floating around about it, that is a good mix that can solve the problem. And I think it's the same in almost every situation. If you look at the communication model behind things, that is what constrains the system. I think it's Conway's law, isn't it, that any organization is constrained to be the communication system that underlies it. Thank you.